solve equations involving logarithm. We're going to solve log of 3x plus 2 is equal to 3 with the base 5. What we need to do in this case is to use the property that we had before, where log of x is equal to y with the base b. We should be able to convert this to this exponential form. So that would be the base of the logarithm would be the same as the base of the exponential. So b to the power of y would be equal to x. That's how you can go back and forth with this. But in this case, we're going to take this here and convert it into its exponential form. As you see here, the base of the log is 5. So we write 5 to the power of 3 here. 5 to the power of 3, just like what we have here, b to the power of y. 5 to the power of 3 must be equal to, whatever, in this case my x is 3x plus 2. So 5 to the power of 3 is equal to 3x plus 2, or 3x plus 2 is equal to 5 to the power of 3. By doing this, you don't have any log here. That's all we have to do here is to solve for x, isolate x. 5 cubed is 125. To isolate x, I'm going to subtract 2 from both sides of the equation. That becomes 123. Divide both sides of the equation by 3. There it is, 41. Check to see the log of 3 times 41 plus 2 is equal to 3. It's true. So the solution is 41. Solve a logarithmic equation. You have solved log of x plus 1 to the power of 5 is equal to 3 to the base 3. So to do this, we need to convert the logarithm into its exponential form. Here, if I have log of x is equal to y to the base b, that's the same as b to the power of y is equal to x. So in this case, my base is 3. So it would be 3 to the power of 3 is equal to all these stuff that we have here, x plus 1 to the power of 5. So this is my x, really. My base is 3, and my y is also 3. So it would be 3 to the power of 3 is equal to x plus 1 to the power of 5, or x plus 1 to the power of 5 is equal to 3 to the power of 3. 3 to the power of 3 is equal to 27. X plus 1 to the power of 5. In order to solve for x, I need to eliminate this exponent 5. If I raise both of these sides to the power of 1 over 5, then I can reduce this 5, or take a 5th root of that. So if I raise both sides of this equation to the power of 1 over 5, that 1 over 5 and 5 reduces to 1. This would be 1 over 5. So remember, 27 to the power of 1 over 5 is a 5th root of 27. We call nth root of a to the power of m the same as a to the power of m over n. So we have x plus 1 is equal to the 5th root of 27. So if I subtract x from both sides of the equation, x would be equal to minus 1 plus 5th root of 27. And check our answer easily, substituting for each x value that we found. And we see that it's true. 27 will go to 27. Here we're going to solve this equation here. The left-hand side, I have log of 2x plus 5 plus log of 3. looks like I can combine these two using one of the properties that I learned, that log of x plus log of y would be equal to log of x times y. I can combine them. Remember, the base has to be the same for all of them. So in this case, as you see, the base is 8, the same. So log of 2x plus 5 plus log of 3 can be combined to log of 3 times 2x plus 5. We can combine these into one logarithm. Because from here, I can conclude that if log of x is equal to log of y, if the base are the same, from here I can conclude that x must be equal to y then. That's exactly what we're doing here. You're saying that if log of something is equal to log of something else, the base are the same, then in this case 3 times x plus 5 must be equal to 33. So I don't have any log anymore here, so I can solve for x. And to do this, we can distribute, or we can divide both sides of the equation by 3, so I don't have to deal with this large number. If I divide both sides of the equation by 3, in the right hand side I get 11, then I get 2x plus 5. To solve for x, I subtract 5 from both sides of the equation and divide both sides of the equation by 2. Then I would get x equal to 3. You can check our answer by substituting for each x 3 and conclude that the solution set is 3. Here is solving this equation for x. In the left-hand side, we have log of x plus log of x plus 15. So I can combine these two using the fact that log of x plus log of y is equal to log of x times y, knowing the base are the same. So in this case, I have log of x plus log of x plus 15. I can write it as log of x times x plus 15. I'm combining this into a single log. So at this point here, I can rewrite this as its exponential form. We call that log of x equal to y. I can write this as, if the base is b, it would be b to the power of y is equal to x. So to drop this log here, I need to convert this to this exponential form. That's exactly what we're doing here. The base here is 10. If there's no number here, it means it's 10. So there we have 10 to the power of 2 is equal to x times x plus 15. So x plus 15 is equal to 10 squared over 100. Distribute the x, I get the second order equation, x squared plus 15x. If I move the 100 to the left by subtracting 100 from both sides of the equation, here I get the x squared plus 15x minus 100 is equal to 0. We can either factor this or use quadratic formula. Looks like it's factorable. 20 and 5 would be the product of 100, and if I have plus 20 minus 5, that would be sum of 15. If you still have a problem with factoring, please refer to my lectures on factoring. And once you do that, then we can set each of these parentheses equal to 0. We get x plus 20 equal to 0, so x equal to negative 20 and x equal to 5. Now, the value negative 20 must be rejected as a solution, since it leads to the logarithm of a negative number in the original equation. So the only solution we have is 5. Solving a logarithmic equation, step number 1, transfer the equation so that a single logarithm appear on one side. We're going to use our properties that we learned. Use a product or quotient to combine them into a single logarithm. Use the product rule or quotient rule or logarithmic to do this. Step number 2 is to do one of the following. Either use this property here. If log of x is equal to log of y with the same base, you can conclude that x is equal to y. Or you have to sometimes write this in its exponential form. If I get log of x equal to k with the same base b, that would write it as b to the power of k is equal to x.